Hello everyone, I'm Paul and today we're solving problem 3195. Find the minimum area to cover all ones 1. This is medium and the logic for this is simple, so let's start. We are given a binary grid such as this one, and we need to return the area for the smallest rectangle which covers all ones in the grid. So let's say we're given this. Here is the visual representation of the grid, and this is the smallest rectangle which covers all ones. And the area for this rectangle is 2 times 3. So the result for this is 6. Now my first intuition here is the following. We can iterate every value in the grid, and whenever we find the 1, we just keep track of the maximum and minimum bounds. So we can have 4 variables. We will call this top, bottom, left, and right. And now we are iterating this grid. First we are here. Given that this is 0, we continue. Now we are here. This is a 1, so we can update our bounds. For example, top is the smallest row. Right now we are at row 0. This will be initially n. In this case, n is 2. So this is initially 2. And given that we are at row 0, we can keep here the minimum value among 2 and 0, which is 0. So now top is 0. The bottom bound will be initially 0. And here we are keeping the maximum among the current row and bottom. And the maximum among 0 and 0 is 0, so we keep 0. Similarly, the initial value for left will be m, which is 3 in this case, and the initial value for right will be 0. And for left, we are keeping the minimum value among the current column, 1 and 3. And the minimum is 1, so here we put 1. And for right, we keep the maximum among 0 and the current column, which is 1. So we replace this with 1. So this is the state for every bound when we are here. Next we are here, this is 0, so we continue. Next we are here, this is 1, so we can update our bounds. First, top is the minimum among the current row and 0. And the minimum is 0, so we keep 0. Bottom is the maximum among 0, the current row, and the maximum value here is 1, so we put a 1. Left is the minimum among 1 and the current column, which is 0, so we replace this with 0. And right is the maximum among the current column, 0, and right, which is 1, so we keep right here. So at this point we have this state, which corresponds to this rectangle. Now we are here, this is 0, so we continue. Finally we are here and this is 1, so we can update every value in our state. This is the minimum among 1, which is the current row, and 0, so we keep 0 here. This is the maximum among 1 and 1, so we keep 1. This is the minimum among the current column, 2 and 0, so we keep 0. And this is the maximum among the current column, 2 and 1. So now this is 2. So finally we have this state which corresponds to this rectangle. And finally we need to return the area for this rectangle. And how can we get the area? Well, this is simple. We just do bottom minus top plus 1 times right minus left plus 1, and we just return the result for this. So we do 1 minus 0 plus 1 times 2 minus 0 plus 1. This is 2 and this is 3, and 2 times 3 is 6, so we return 6. Time complexity for this is big O of n times m, because we are iterating this grid, and this is fine because n is 1000 and m is 1000, and we can handle 1000 square. and space complexity will be big O of 1. So now let's go with the code and hopefully you will get the idea. First we say n is the length of grid, m is the length of grid 0. And the initial state is the following: top is n, bottom is 0, left is m, and right is 0. And now we can iterate every cell in the grid. So for I in range n, for j in range m, if the current cell grid I j is a 1, we can update our state. So top is the minimum among top and the current row. Bottom is the maximum among bottom and the current row. Left is the minimum among left and the current column. And right is the maximum among right and the current column. So finally we can return bottom minus top plus 1 times right minus left plus 1. So this is it for the code. Now let's submit this and see if it works. As you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.